Okay, let's do our practice test together. So the first few problems are going to ask us to graph and explain some things about our basic functions. So for each of these, I will give you the graph and I'll give you a lot of blanks to fill in, and you'll have to give 3 of these back to me on the real test. So it'll be vary depending on which version of the test you get. So you need to know all of them. So the absolute value function, the algebraic representation is y is equal to the absolute value of x. To graph it, we always start by graphing our x and y axis. Nothing fancy, just label them. Now, to build the graph, I do want some points. I don't want you to just loosely sketch it where it doesn't mean anything. So give yourself a table and pick yourself a few points. So I said when you have an input of 0, well, that would be the absolute value of 0 is 0. When you have an input of -1, the absolute value of that would be 1. And when you have an input of 1, the absolute value of 1 would be 1. So you can go ahead and graph these 3 points. You can graph some more if you'd like, but that's enough to graph that basic function. And that's all I'm looking for. Now, the domain would be as far left to as far right as the allowable values we have. We have -infinity to positive infinity. Our range is our lowest value, which our lowest value we can see is 0, and it includes that, and our highest value is infinity. And then last is an even or an odd or a neither function based on symmetry. You can see that if you folded it in half along the y-axis, it would lay on each other. So the function would lay down on each other, so it's an even function. You can see one side is a mirror of the other side. So if it's about the y-axis, that is an even function. Let's look at our next problem. This one asks us to give the algebraic representation for the square root function. The y is equal to the square root of x. Be aware, and if it says square root, we need to put that radical. So let's go ahead and graph this one. So I added my axes, and I made a table. So when I have x is equal to 0, the square root of 0 is 0. X is equal to 1, the square root of 1 is 1. X is equal to 4, the square root of 4 is 2. And x is equal to 9, the square root of 9 is 3. So let's graph those points. And then sketch it out. That's all I'm looking for here. Okay. The domain from left to right, the farthest allowable values for x are 0 to infinity, including the 0. And our range will be 0 to infinity. Okay? And this does not mirror itself across the y-axis. So it was upside down. Would it look the same? No. So we know it's not odd. So it's a neither. Okay? Our cube function, that's going to be y is equal to x cubed. Let's graph this one. So I made a table, and I added the x and y coordinate system, the axes. So if x is 0, 0 cubed is 0. If x is 1, 1 cubed is 1. If x is 2, 2 cubed is 2 times 2 times 2. That's 8. If x is -2, -2 times -2 times -2 would give me -8. And if x is -1, then our output would be -1 times -1 times -1, which would be -1. So let's go ahead and graph these points. We've got a loose sketch there. That's pretty nicely drawn. So let's look at our domain. Now remember, this is really tipping left to right, both sides. So our domain is -infinity to positive infinity. And our range is also -infinity to positive infinity. Okay? Now, symmetrically, if I look at this, it does not mirror about the y-axis, so it is not even. If I turn it upside down, does it look the same? Yes, it does. So it's an odd function. Our next function is the cube root function. So make sure you're aware of that's a root when you see these. So it's going to be y is equal to the cube root of x. So let's go ahead and graph this one. Chose some input values that will easily be able to take the cube root of them. So 0 input gives me a 0 of output. The cube root of 1 is 1. The cube root of -1 is -1. The cube root of 8 is 2. And the cube root of -8 is -2. Okay, let's graph these points. Okay, so I've sketched in those points. Okay, now my domain, the farthest left, -infinity to the farthest right, positive infinity. My range, -infinity to positive infinity. Okay, let's do the next one. Okay, so the square function now is going to be y is equal to x squared. Okay, so let's graph this one. Okay, so I went ahead and sketched in my x and y axes, and I made a table. Okay, so when I have an input of 0, 0 squared is 0. Input of 1, 1 squared is 1. Input of 2, 2 squared is 4. Input of -1, -1 squared is 1. Input of -2, -2 squared is 4. So let's graph those points. Okay, we can sketch it in and we see it's a parabola. So our domain is -infinity to positive infinity, and our range is 0, our lowest value, to infinity. And we do include that 0. Okay? Is this an even, odd, or neither function? Well, you can see that it is mirrored about the y-axis. Right? So it is going to be an even function. Okay, the reciprocal function. So this is going to be y is equal to 1 divided by x. So let's graph this one. Let's go ahead and make a table for this one. Now for this one, I'm just going to pick some values that might help me. So if I put 0 in, 1 divided by 0 is undefined. Right, so we're not going to do that one. Let's try 1. How about 1 over 1 is going to be 1, and then 1 over -1 will give me -1, right? Let's just pick a couple more values, see if it'll help us. Let's pick 5 and -5. So if I say 5, right, so 1/5, and -5, I would get 1 over -5, so -1/5, right? Let's pick a couple more values and see if that helps us. How about if I do 1/2? So I'd say 1 over 1/2, that's going to give me 2, right? And then -1/2, that's going to give me 1 over -1/2, it's going to give me -2. Let's graph these. So I sketched it in. So you can see that there's a vertical asymptote that's running along the y-axis and a horizontal asymptote that's running along the x-axis. Okay, what's our domain? Well, our farthest left value for x would be -infinity. Now, but we notice we can't have 0. 0 is not included in our domain. It's undefined, so we're going to make sure we put a parentheses on that side, and we're going to unite it with the other side of the graph, 0 to infinity. We're going to do the same thing with our range. Our lowest point is going to be -infinity, but it's going to go to 0 and then not include 0. And then 0 to infinity. Okay? Is this even, odd, or neither? Well, let's think about it. If we rotate this upside down, does it look the same? Yes, it does. So it's going to be odd. Okay? Okay, and we have one more, the identity function. So the identity function says that y is equal to x. So let's just go ahead and sketch this one. We should be pretty familiar with. It's a nice linear equation. So I went ahead and sketched that line in. Our domain is -infinity to positive infinity. Our range is -infinity to positive infinity. And symmetry. So it's clearly not mirrored about the y-axis, but if I hold this upside down, is it the same graph? It is. So it's odd. Then I'm going to ask you to describe what's happening for a couple of equations. So once again, this portion of the test will be no calculator. Okay? So for the function 1/5 x squared minus 3 is equal to y, what is the basic function? All we're looking for is y is equal to x squared, or you could say x squared is equal to y. Right? So, or you could say the square function. I would accept either the name or the algebraic representation. Describe all the transformations. Okay, so we can see there's a constant added on right here. So that indicates that there is a vertical shift. And since it's a -3, it's going to be down 3. So our first one will be vertical shift down 3. Okay? Now, our x expression is just x, so we don't have any horizontal shift. But there is a 1/5 here. And since it's a fraction, it's between 0 and 1, right? We know the absolute value. If the absolute value of that c is between 0 and 1, then we know it's going to be a vertical compression of a factor 1/5. Let's look at our next problem. So this function is clearly a cube function. So I can write it out, or I can write the algebraic representation. Either one is correct for me. Okay, and then it says describe all the transformations. So I see that there is a number, a constant by itself. So since it says +7, we know we're going to go up 7. Okay, next we're going to look at the expression, if there is one, with the x. If there's an expression, if it has a -4, we know it's going to be a horizontal shift. If it's a -4, it will go right 4. If it had been a +4, we'd go left 4. Okay? And then last, we're going to look right here. It's a reflection. And since the reflection is outside of the x expression, we're going to say it's across the x-axis. Okay? And since it's across the x-axis, we are okay with our horizontal shift being right 4. Okay? Let's move on to our next problem. Question C3 says, is this a function? So the first thing I always do is I look at the inputs. If there are any repeating inputs, that's like a warning, high probability that it is not a function. So let's look and see. Uh-oh. So I have 200 and 200. So my input of 200 has 2 different outputs. We know the definition of a function is that every input can only have exactly 1 output. So this is clearly not a function. Okay, next is ask me what the domain is. Since these are distinct points, we can use set notation. So we'll use the set brackets, and I'll list all my x values for my input. You can notice I didn't need to list 200 twice. I only need to include it once. Now we're going to do the same thing for our range. We're going to list all of our outputs, our y values. Okay, let's move on to number 4. Number 4 also asks, is this a function? When it's given in graph form, we can easily check this with the vertical line test. The vertical line test means I can take a vertical line and pass it through my graph, and at most, it will intersect the function at one place at a time. So yes, this is a function. And why? Because it passes the vertical line test. And you may write, if you like, VLT. I'm fine with that. I'll know what you mean. What is the domain? So the domain, since this is continuous, will be the farthest left value, the smallest x value allowable. In our case, it's going to be -2, and our largest value will be 2. Now I include the n values since they're closed circles. Okay? My range, we want all the possible outcomes that go with my domain. So we know our lowest value is -1, and our highest value is 1, and we do include them, so we use brackets. Okay? We know we would not include them if they were like an open circle or something that indicated that it was not included. Okay? Now, increasing and decreasing intervals. Reminder, with increasing and decreasing intervals, you're going to always use parentheses because we don't include the ends, we don't include the valleys or the mountaintops. So let's look and see where our slope is increasing. Where is it going uphill? See, we're going uphill in this area. Now, the trick on describing an interval is you use the x-axis to describe it. Go ahead and transfer that location of where it turns to the x-axis. Now use an open circle because I'm not going to include those points. I don't want to include the endpoints where it's turning, the valleys and the mountaintops. Instead, I want to include this area. So I can describe that as negative 0.75 to positive 0.75. And I'm going to use parentheses because I'm talking about an interval. Now my decreasing interval will be where the green is. These are where we're going downhill. So we want to transfer the locations where I'm going to be changing from increasing to decreasing onto my x. Okay, and now I want to describe the region I'm trying to go is from here to here, right? So I can transfer that one too. And over here. So my decreasing interval will be from -2 to 0.75, negative 0.75. And it's going to be with 0.75 to 2. And I use a U to show you that I'm uniting those two intervals. Number 6 wants us to look at these functions and decide if they're even, odd, or neither. So let's look at function number A, letter A. So we can rewrite this as x cubed minus x is equal to f of x, because we know this is another name for y, okay? Now let's figure out what would f at negative x be. In other words, everywhere there's an x, we're going to put a negative x. Okay, so I replaced in my equation, everywhere there was an x, I put a negative x. Okay, now let's simplify that. F at negative x is equal to negative x plus x. So I want to compare f of x to f at negative x. And I'll see that f of x is not equal to f at negative x. So therefore, it is not even. Once I rule out even, I try odd. The way I check for odd is I put a minus sign in front of our original function. Okay? In other words, I multiply our original function times -1. And I simplify it. So I get negative x cubed plus x. So negative f of x is equal to negative x cubed plus x. Now I want to compare this to f at negative x. So I'm going to compare these two. Okay, so I have negative x cubed plus x, and, oh, I seem to have left out a cubed here. Let me fix that. Okay, so you can see that these are the same. So f at negative x is equal to negative f of x. Therefore, our function is odd. If it were neither odd or nor even, then we'd put neither. Let's review the trick for using the calculator to help us determine if it's an odd or even or neither graph. So I want to enter in my function. I want to graph it. Okay? Now, if it's mirrored about the y-axis, then we know it's even. Well, you can see it's definitely not that. Now, to see if it's odd, we want to turn our calculator over so it's upside down. Okay? If you notice, when I turned it upside down, it looks identical to the way it started. So that is an odd function. Let me do that one again. So you take your calculator and you just turn it upside down. If it's identical to the function when you started, it is an odd function. Let's look at B. So this time it says f of x is equal to negative x. Okay, let's check out what f at negative x would be then. F at negative x would be wherever there was an x, I'm going to now put a negative x. So it would be x. So we can compare now f of x and f at negative x. If they're equal, it's even. But clearly, they're not equal because negative x and x are not the same thing. So it is not even. Now we're going to check to see if it's odd. I take my original function and I put a minus on the outside. Okay? So it's the same thing as multiplying your function times -1. So we'll get x. So negative f of x is equal to x. Okay? So if we notice now, f at negative x and negative f of x, they're equal. They're both equal to x. So this is the definition of an odd function. I could graph this on the calculator, and once again, I could turn it upside down and it will look the same as it started. Let's try part C. So we're going to rewrite y as f of x. And now we're going to try f at negative x. So where there is an x, I'm going to put a negative x. And I'm going to simplify that. And I can clearly see that f of x is equal to f at negative x. This is the definition of an even function. Let's check this one on our calculator too. So I'm going to clear my grapher, and I'm going to enter 7x squared plus 3. And then I'm going to graph it. And I can see that it's clearly symmetrical about the y-axis. In other words, it mirrors about the y-axis. So it clearly is an even function. So rate of change, remember these are just basically slope problems. So we need an input and an output. So this is going to be our input for point 1. And this is going to be our input for point 2. Okay, so what is f at 0 and what is f at 10? I'll replace all x's with my inputs, and then I'll use my calculator if necessary. Just like we've learned before, if we have an input, we can write it as an ordered pair and an output. And we have an input of 10 and an output of 83. Now we're just going to use our traditional slope formula to find that average rate of change. So I'm going to fill this in, and I get a slope of 8. This is my average rate of change. Okay, let's do the second part. Okay, same thing. This time we don't have a f of x. We're just going to rewrite that y as f of x. And we're going to fill it in with an input of 3 and an input of 8. This creates 2 points, 3, 36, and 8 to 56. And I can write my slope formula and find the slope of these 2 points. And then my average rate of change is 44. Problem 8 asks us to find the x and y intercept. This is an easy one. Just remember that at the x-intercept, y is equal to 0, and at the y-intercept, x is equal to 0. Okay, so for part A, when y is equal to 0, we just replace y with 0. And we get x is equal to 24. So our x-intercept is 24. Or if you wanted to, you may write it as an ordered pair. I'm fine with that. Okay? Similarly, to find the y-intercept, we're be x equal to 0. And we get y is equal to -16. And you could write that as just -16, or you could say 0, -16. Now, part B asks us to find the best window setting on the graphing calculator. So what I would do is I would look at my 2 points, 24, 0, and 0, -16. And I'd say, what is the smallest x that I need? Well, it needs to be smaller than, and I would look at my x coordinate. I have a 24 and a 0. So it has to be less than 0, okay? And what is my biggest x coordinate? Well, it's 24. So it needs to be greater than 24. Okay? Let's check out my y. My smallest y is negative 16, so I need to be less than negative 16. And my largest y is 0, so it needs to be greater than 0. Now we can check which window meets these requirements. Okay? So let's see. If I say the first one, my x minimum is negative 5, well, that is less than 0. And my x maximum is 25. That is greater than 24. So far, those look good. My y's, negative 20 is less than negative 16, and 5 is greater than 0. So this one will work. Okay? If you check the other two, they won't work. Number 9, it's a piecewise function. This is basically like 3 different equations that went for different inputs. So it says when our input is negative 8 for part A, well, which of these qualifiers will make when x is negative 8? Well, negative 8 is less than negative 5. So I'm going to use this one. So it tells me when x is less than negative 5, which is what I have, that my output is 7. Okay? Next, I look at an input of negative 5. Well, less than negative 5 is not equal to negative 5. So when it's equal to negative 5, I need to use this equation, negative 5x squared plus 1. Okay? Let's evaluate that for when an x is negative 5. At negative 124. Now, what is f at negative 3? We have to see which of these qualifiers does that fall into. So at negative 3, that's not less than negative 5. It's between negative 5 and 0, though, so it would be this one. So we're going to use that same equation, but this time we're going to evaluate it for x of negative 3. Get negative 44. What about when x is 7? Well, 7 is clearly bigger than 0, so it's going to be 1 over 7. Okay? Do you think linear regression would be a good model for this scatter plot? Explain your decision. Well, it looks to me like as the years go on, the percent of smokers is decreasing, and I think I probably could do a nice straight line to at least sort of model what's happening with my data. So I'm not looking for anything fancy, just that you realize that it's that the relationship of the variables and that it can be modeled with a line. Okay? Number 11, write the equation of the line in slope-intercept form that passes through these 2 points. So when we have 2 points, we always need a slope and a point. So let's pick one of them. And then we need to find the slope. Using my slope formula, I get the slope is 2. Once I have a slope and a point, I can either use point-slope method or I can use solve for b using the slope-intercept method. Okay, so I put in my slope of 2 and I put in my point as negative 6, 4. Let's distribute. And then I want to solve for y since it asks for it in slope-intercept form. So I get 2x plus 16 is equal to y. Let's also solve for it using slope-intercept method if you like that better. So in this method, we solve for b. So I write y is equal to mx plus b. I replace x and y with my point and m with my slope. And I solve for b. Oops, let me fix that, sorry. That was a 4, so that's going to be 16. Once I know what b is, I just rewrite my slope-intercept form with y is equal to, but in place of m, I put my slope, and in place of b, I put my y-intercept that I solve for. Okay? Number 12 asked me to write the equation of the line that passes through a point, and then they give me a clue that it's perpendicular to the line, y is equal to 4x plus 3. You always need 2 things to write an equation for a line, a point and a slope. Well, they give me the point, 8, 12. But they give me a clue about the slope, okay? This phrase is nothing more than a clue to get our slope. It is not our slope. It is not our equation for our line. It's a clue to get our slope. We have to know that perpendicular lines have slopes that are opposite and reciprocal. So opposite signs and reciprocal, which means flip it over. Okay? So parallel lines have the same slope, but we have perpendicular lines. Okay? So we look at this equation. This is not our equation, but we can get the slope of this line, and it's 4. So since we're perpendicular, our slope, this is a symbol for perpendicular, will be opposite sign. So it isn't positive, so we're going to be negative, and it's going to be flipping it over. So instead of 4, it's going to be 1/4. Okay? That's all we're going to use that phrase for. So sometimes it's handy to cross it out. Once you have your slope, just cross it out. I don't want you to use it ever again. It's just a clue to get your slope. Now we have our point and we have our slope. We can use whichever method we like, the point slope formula, or solving for b using slope intercept method. So I get negative 1/4 x plus 14 is equal to y. And you could use the other method, that's fine. You'll end up getting the same equation. Okay? Next, they asked me to graph a piecewise function. So you might want to review graphing if it's been a while. When you're doing a piecewise function, look at where it changes the x value. So it says that at x greater than 2 or less than 2 is going to be some kind of change. So values that are less than 2 will be x squared, and values that are greater than or equal to 2 will be 8. Let's do the side that is the greater than or equal to first, because that's the easier side. Okay, so it says that when x is greater than or equal to 2, it's going to be 8. That means it's constant. And I'm going to use a closed circle because it included that endpoint. Okay? Now the other side, it says that when x is less than 2, so we want to make sure that we don't include the 2 side, but I want to graph x squared. And we know that x squared is just our basic function like this. Now at 2, when x is 2, our value for our output will be 4, 2 squared. But I'm going to put a big open circle there to remind me that I'm not going to include it. Okay? There, I graphed it. I just made sure that I've made an open circle when the input is 2 so that it knows that the output is really 8 at 2. So in problem number 14, we know that the absolute value is the yellow, the V, right? And we want less than, so we want to go where it's below the 6. If it had been greater than, we would go where it's above the 6. Okay, but it said less than. So we know it's less than where I drew the yellow, so I want to transfer those points down here to the x-axis. Okay, now be careful on these. You have to look at the sign. It says less than. Since it doesn't say less than or equal, it's going to be an open circle. Had it been a less than or equal, we would make it a closed circle. And then we know we want this area in here. So our answer will be -3 to 9, and it will be parentheses. Okay. The next problem asks us to solve and graph the solution set on a number line. So first, our first step is to isolate the absolute value by itself. Now we want to think about this. When it's greater than or equal, we're saying that we want the distance from 0 to be greater than or equal to 35. So on the number line, we're talking about these outside regions. We want this to be greater than or equal to 35. So we're going to set it equal to 35, and we're going to set it equal to -35. And when we solve, we're going to realize that we want the outside regions, okay? If it had been less than or equal, we would want the inside. We would want this portion. But since it's greater than or equal, we're going to want those outside regions. Okay, so let's solve each of these. So when I graph these 2 points, so 20/3, and you're welcome to leave it as an improper fraction, that's fine with me, and just label it. Okay? And we know that since it's equal, we're going to put a closed circle, and then we're going to color in this direction because it's greater than or equal. Okay? Now, the next problem asks us to find the difference quotient. And the difference quotient, it's simply an extension of the slope formula. So just to make sure you see it, you know that every point has an input and an output, right? That's what we call an ordered pair. So if we wanted to find the slope formula, right, between 2 points, we can say this is our first point, and our second point, maybe it's a little bit away from x, so it's x plus h. So our output would be f of x plus h. Now let's make the slope formula for these 2 points. So we'd say the output of one minus the output of the other over the input, which is going to be x plus h, minus the input of the other one. Now, you don't have to memorize this because you really can derive it quickly if you want. So it's going to be f of x plus h minus f of x, and then x plus h minus x, well, that's just going to be h because those x's are going to cancel out, right? And this is what we call the difference quotient, okay? So we know what f of x is equal to. We're already given that. So it's equal to 7x squared plus 6, okay? So we need f of x plus h. And to find f of x plus h, all we're going to do is wherever there's an x, we're going to replace it with an x plus h. And we're going to expand that out, okay? So I have f of x plus h is equal to 7x squared plus 14xh plus 7h squared plus 6. Okay, now I'm just going to substitute each of these values into our difference quotient formula. I substituted each of those into my difference quotient, and I ended up what I have over here in pink. Okay, so now I just want to simplify it. If I simplify it, I have to remember that I have subtraction of polynomials. Make sure that you distribute that minus. Okay, and then we can see that the 6 minus 6 will cancel out, and the 7x squared minus 7x squared will cancel out. That will leave me 14xh plus 7h squared all over h. But you're not done yet. Make sure you factor out the h, and you're left with 14x plus 7h, okay, over h, and your h's will cancel out, and you'll be left with 14x plus 7h. So your answer is 14x plus 7h. Number 17, you may do this by hand or with the calculator. Be careful. It says, let x be the year since 2005, okay? It does not say let x be the year. It's already been defined for you, and it says y is the total revenue. So let's make a quick table. Since it's year since 2005, it's going to be 0, 1, and 3, okay? Because we have 2006 minus 2005 is 1, and 2008 minus 2005 is 3. Okay? Now, all I need is 2 points to write an equation for a line. I have 3, okay? But I can choose 2. I'm going to pick my first one and my last one if I do it by hand. And I'm going to say my slope is, so it's going to be 8761 minus 5257 over 3 minus 0. Okay? I get that the slope is 1,168. Now, if I want to use my point slope formula, I can say 1168 times x minus 0 is equal to y minus 5257, and I can solve easily for my slope-intercept form of my equation, and I'm left with 1,168 x plus 5257 is equal to y. Now let me run you through how you can do it in the calculator if you want to. So let's enter our data. So to enter our data, we hit stat, okay, and then 1. And then I'm going to enter in 0 and 1 and 3. Now, to go on this side, I'm going to enter my data in on my output, okay? And then, okay. So I have my data entered in. I'm going to hit stat, but this time I'm going to hit calc and 4 because I want linear regression. Okay, and then I'm going to tab down with my arrow key until I get to calculate, and I'll hit enter. And it tells me that my slope A on the calculator is 1168. And it tells me that my y-intercept is 5257. Same equation, different way to get there. You may use either method on the test.